everyone, and welcome to our Thought Leadership Series discussion on Emergency Responder Radio Communication Systems, or ERRCS, brought to you by Symphony Technology Solutions, Atlanta's leading smart building systems integrator. My name is Katie Galley. I am the Social Media Marketing Manager here at Symphony, and I am joined today by my co-host, Trey Gaskins, the President of our Internet of Things division. How are you doing, Trey?
Katie, I'm doing great.
Awesome. Well, I'm super excited to dive in with you. And you want to intro Eric?
Yeah, we're keeping it in-house today. We have a lot of talent within the Symphony team. And I'm proud to introduce Eric Fickner, our Chief Operating Officer, and my good friend and business partner. And today we're going to be talking about the elusive topic of ERRCS and why we need it. What were some of the reasons that ERRCS came into place? And really what the acronym stands for. So with that, Eric, why don't you tell us how many syllables are in the definition of ERRCS and a couple of the different names and why we need it?
Sure. Emergency Responder Radio Communication System, that's the International Fire Code, 17-syllable title. ERRCS is one ugly syllable, so we go for ugly over lengthy in this business.
What are some of the other names for that, Eric?
You'll hear it sometimes called Public Safety DAS. You'll hear it called BDA, which stands for Bidirectional Amplifier. You'll sometimes hear it just simply called Emergency Communication System. The National Fire Code gives a different label. I actually cataloged once and came up with 8 different labels or names I'd seen used in different sets of specifications. So not just people on the street, but literally an engineer had put together a spec, and I have a list of 8 different ones.
Wow. So we're working on a lot of different, we do a lot of new construction projects, and as a low voltage systems integrator that offers not only the ERRCS but DAS and low voltage things like audiovisual, access control, surveillance, video intercoms, all the voice video data. We're doing a lot of ERRCS projects right now, and we're finding that a lot of the ERRCS projects are not budgeted, and a lot of our customers are going, why do I need this? Seems like a new requirement. What made the ERRCS systems come into existence?
The development of these types of systems really springs from a tragedy, which is 9/11. So it's a historic and graphically heartbreaking moment when we recognize that when those 2 towers came down, there were over 300 first responders that were killed, and many of whom could have been saved had they been able to hear their captains outside the buildings telling them to get out, especially in the second tower. So once the first tower came down and people realized the second tower was in danger, all of the fire captains and the police captains were trying to communicate to their firefighters and police officers to get out of the building, and many of them didn't hear the call, and so they were actually, unfortunately, killed in that tragedy. And that prompted a great deal of discussion. There was a whole 9/11 commission that took all the way till 2005 to come up with recommendations across a whole broad array of various security issues. Of course, we had impact with how we travel and all that, but one of the big recommendations that came out was that buildings should be equipped with amplification systems that effectively rebroadcast that emergency radio network inside buildings. And what's happened is as modern buildings have become more and more energy efficient and compliant with increasingly stringent energy codes, there's a corresponding increase in the difficulty that a radio signal has in penetrating through that building envelope. The more energy efficient your building is, the more it is effectively immune to outside radiation. And that's what makes it energy efficient, but unfortunately radio signal is outside radiation. So probably had we not had 9/11, we would have had to do this anyway, but it certainly accelerated the recognition that we need to have a way for first responders to communicate within their buildings. Now, this is separate from commercial distributed antenna system, for the major wireless carriers, Verizon, AT&T, T-Mobile, Sprint. These are separate radio frequencies, separate devices, a whole separate communication network. And so It is a separate system. I can talk later about how they sometimes can converge. So that initial 2001, 2005, and the International Fire Code in 2012 first really captured, hey, now you have to demonstrate that you have signal coverage if you don't put in firefighter jacks. And so what's been happening is, in addition to the recognition that there's not radio coverage, in the old days you had firefighter jacks, those plug-in phones that firefighters carry, and people realized, well, ambulance drivers don't carry firefighter phones, police officers don't carry firefighter phones, what about those guys? And so there's pretty much been a strong movement, code-wise, industry-wise, and amongst all the different first responders, that really we need a radio network inside the building that allows all first responders to be able to communicate effectively with each other in the building and with the outside world. There you go. And now we're in a situation here, my goodness, next year, it'll be 20 years later, where it's fairly much a common and ubiquitous requirement that you need to provide that re-amplification.
So Eric, when a property is under construction, what are some of the first steps that you recommend that developers and general contractors do to understand if they're going to need an ERRCS system and how to work with the fire marshal?
Well, hopefully they've budgeted it, and generally speaking, earlier in years, people put in their contingency budget. I think now most people are recognizing it's almost always required, and so they're kind of moving it into more of a fixed budget item. Starting with that, the really critical thing is communication with the fire marshal, and I would argue, not so much out of self-interest, but for the interest of the developer, that you should have an informed integrator doing that communication. We've worked in hundreds of jurisdictions around the country, and virtually no, and I'm talking about municipalities, cities, and counties, not states, and virtually none of them match how they operate. They have different codes they work from, whether it's International Fire Code, the National Fire Protection Association handbook, with state codes. So Florida has a Florida Fire Protection Code. Even local municipalities often have special code. Different cities, especially larger cities, will have their own particular fire code. And then the requirements of those fire marshals will often change as they become more educated. So we'll work in a jurisdiction, and then the next year we'll work in that same jurisdiction. We don't assume that the same requirements exist. We always touch base with the fire marshal. We walk them through the code iteration. A lot of times we're educating the fire marshals because they don't necessarily understand it. They're not radio guys. They're firefighters. They might know fire alarm. They don't necessarily know radio. And they're concerned about making sure that when their people are in that building that it works. And so they're trying to figure out how to apply code and make it work. That just creates a situation where you've effectively got to hire a translator. And that's how I think of one of our primary initial responsibilities is to translate for the developer what the fire marshal is requiring and do everything we can to enable it to be as cost effective as possible.
So Eric, some people are thinking, well, as I'm building my project, should I put in Conduit in case I need the system, or should I put cabling in? What's a typical recommendation for most customers?
That is a great question. I wish I could say there's one common recommendation, but this goes back to the whole idea of municipalities. Virtually, without exception, you need to have a design that's been done, and a lot of times you need to have it when you're pulling your initial building permits, so early on in the process. So that design has to be done by a professional, has very ridiculously expensive software, which we have several seats of, so we have multiple ridiculously expensive softwares. And so that shows that propagation based on a system. It's submitted per that local fire marshal's requirements. A lot of times, more than just the design, they want all kinds of other information. You submit it and you get it approved. Okay, now you got a fire. Now you've got an approved, set of drawings from that fire marshal. That's the first thing you need. We recommend that if there are not survivability requirements, that you put in the cabling. The cabling is less expensive than the conduit, and so why would you put in conduit and then pull cabling later if you need it? Now, the caveat to all of that is in some jurisdictions, they are requiring what's called a level 1 survivability for those horizontals. So you got the vertical rising up the shaft. That's virtually everywhere. That's a 2-hour rating. So you got to have the building effectively supply a 2-hour shaft. But as you break out onto the floors, your horizontals, most jurisdictions follow the recommendations of the IFC and the NFPA and allow for basically plenum run cable, just like all your other low voltage cable. A few jurisdictions, however, want a level 1, which is that 1-hour survivability, and that does need to be in conduit. In those cases, you do want to run empty conduit, but you got to do it per the design. So you have to have a design first, because that conduit's got to get to and terminate at each antenna or splitter location.
Gotcha. So basically, you're saying that if you do your research, talk to the fire marshal, go ahead and put the infrastructure, get a design done, get the fire marshal to approve it, and in many cases, putting in the infrastructure is going to be more cost efficient than putting in the conduit and cabling later. And then, at what point do you test to see if you need the system or not?
So the dirty dark little secret is, of the hundreds of buildings we've tested, every single one of them has failed in some measure. So one of the things I want to just get people to understand, developers, owners understand, is you are going to need a system. Even if you don't have low E glass, your building core will have shaded areas that don't match. If you're not familiar with how the testing works, you have to grid out each floor. So you got to test each locale, effectively 20 or 40 different locations on each floor, and some will pass in most buildings, but typically some will not, and effectively nearly every time at least a few won't. You're allowed a tiny bit of failing, but not enough to really accommodate. So I'd say the first thing is, when you have that integrator test, don't hope that he's gonna go, oh, everything's great, you don't need a system. We've never seen it happen, not ever once, and it's just a reality. You need to test when the building envelope is complete. It doesn't give you a full picture of the RF source, and especially if you've got a lot of interior walls, but it gives you a full enough to where a good integrator could say, okay, you are well within the boundaries of the threshold, you are close, and if you add interior walls, we're going to have more failing areas, or you're already failing and you haven't even added the interior walls, and so you just need to go ahead and plan on doing it per the design. And so our experience is that you pretty much should plan on a design, infrastructure, and probably at least half the building being covered. And when I say at least half, it depends on the building type. You'll find that a high rise will often 5, 6, 7 floors up pass nearly every spot on the higher floors, but the lower floors and definitely the underground won't. But that's not always the case. And so it's not just you can easily split the building in half. I'm just saying when you test it, you'll find certain areas will commonly fail more often than others.
So Eric, after the system's installed, there's a yearly requirement for retesting. Why do they initiate that?
Yeah, so it's a really good question, and there's actually, if you think about it, it's a life safety system. So it is a radio frequency system, which is just like a Wi-Fi network. It is an RF system and the commercial distributed antenna system. But in this particular case, it's supporting life safety systems. So the way the code's been written, much like a fire alarm system has to be retested, this also has to be retested. And it's you're testing not just the performance of the system, you're testing the battery conditions, you're making sure that what you call the BDA, the bidirectional amplifier, is still reporting all of its fault and alarm conditions. And the reason why you're doing that, one is it's just a good practice with a life safety system. The other is maybe a building went up between you and the tower since you last tested it. So because you've got to get that signal with a directional antenna that's going to point at a tower, right? So you get out on the roof of this 12-story building that you built, and you use fancy spectrum analyzers to find the best signal, and you coordinate with the emergency responder network, usually through the fire department, and you find the right repeater, you aim at that repeater, you get the right signal, you test out everything, you get the proper isolation, everything works great. And then next year, an 18-story tower rises up right in front of the pathway of your donor pointing to that repeater antenna. That's a real possibility, happens all the time. So something could have struck that donor antenna. You know, you could have had a hailstorm that damaged it, really high winds. There's any number of reasons why the signal might have degraded. And now, if it does degrade, the system should catch that and alarm it. But if you had the signal degrade and the system, for whatever reason, wasn't catching the alarm, now you've got a life-threatening condition. So the way the codes have been written is just to say, hey, you know what? Let's just, so all the same commissioning and testing requirements that come initially are all repeated every single year. I will add this: we're finding more and more jurisdictions are saying, not only do you have to have the ERRCS to get your certificate of occupancy, but we want to see your contract for annual retesting in order for you to get your CO as well. That's actually started popping up more and more.
Right, right. Hey, Eric, we've been doing ERRCS for a couple of years. What are some of the major changes you've seen over the last few years, and are there any trends that you're seeing, headed in the future?
Yeah, that's a hard one to answer on a global basis. Kind of particularly, there are several trends. I think the things I would identify are there are two types of boosters: a Class A and a Class B. The Class B boosters are kind of where they're less expensive, kind of a muddier, just a broad band amplifier system. The Class A's have discrete filtering. It's becoming harder and harder to get Class B systems approved. The testing requirements in the new 2018 IFC code make it to where you don't even want to try putting the Class B booster in. So we're seeing an increased stringency around the quality of the booster, so that and what that means is that the signal noise, the interference is being reduced because you're putting a more expensive, better filtered network in. The testing, what you're testing for was just signal strength at one time, and now the newer code versions are actually asking for you to test signal quality as well as signal strength. And so you used to just have a strength measure called RSSI, but now you have DAQ and equivalent SINR. So you have it's very practical. We're in a bit of a transition period where it's a little difficult to get people to agree, but the practicality of it is the code saying, well, it's all well and good if your signal's strong, but if you can't understand it, then it's not usable. So the codes have gone to saying it needs to not only be strong enough to penetrate the building, but we got to know what's going on. Have to be able to, when I'm talking to you, it doesn't need to be garbled. I mean, it's loud, but it's garbled. I'd say the monitoring continues to become more and more stringent, and so the conditions that you monitor have gone from 3 to now 7, and most jurisdictions at this stage are saying we not only want you to monitor it at the BDA and then alarm it in the fire alarm panel. That's how it gets monitored, but we now want a separate annunciator at the fire alarm panel that mirrors all of the conditions that the BDA is showing. Most of the time, that BDA, which is effectively the head end of the ERRCS, is not in the same room as the fire alarm control panel for a lot of reasons. So they want the ability to go into that main fire command center. You got a fire alarm control panel, and to have an annunciator telling you everything you need to know without having to find the BDA. So you're trying to create as much information in that central command center for that firefighter to walk in and go, okay, good. I've got a BDA. It's reporting that everything's working. I know I can safely send my firefighters into this building and not have to worry about losing them. Probably the third trend, I'd say, let me give you three more trends. One is a little bit more density to the antennas, so that if you have an antenna fail or a break or somewhere, that you've still got coverage. I'd say that we're seeing something of a trend towards third-party testing, so that and that's more around local jurisdictions. That's not in the code, but they're saying, okay, Mr. Integrator, you do your stuff, you present your testing results, but I want to get an independent third party in to test. Now, I think that will go away. The reason why you're seeing third-party testing is because the fire marshals are going, I don't know what these test results mean. I need someone to interpret this and tell me whether this guy's full of bull or not. I believe as fire marshals become more and more educated, we'll see a downtrend with respect to third-party testing. And the last trend is around survivability, and that is far and away the most significant factor in impacting cost. So it would seem like it's not that big of a deal, but if you've got jurisdictions, and there are jurisdictions, for example, out on the West Coast that require level 2 survivability for the entire building, that means a 2-hour rating, and there is just a brand new 2-hour rated cable that's come out, and it's literally $100 a foot. That's a whole lot for cable. When you're talking about thousands of feet of cable in a building, or you've got to build a 2-hour chase. So as you see jurisdictions increase stringency around survivability, we talked about the horizontals. For most jurisdictions, you can just run a plenum rated cable, but some jurisdictions now want conduit as well as cable. Well, that doubles, probably more than doubles the cost. If they go to a level 2, a 2-hour rater, my gosh, that probably 300 to 400% increase in cost. So, and I think it's hard to predict where that trend will go. Certain places we're seeing an increase in stringency. Certain other places we're seeing fire marshals say, well, the whole rest of the building isn't rated to that. Why is this one system having higher expectations? But I will say that's the one you have to watch the most if you're a building owner with a budget, because it's what impacts that budget the most.
Great. Thanks, Eric. Hey, just you've mentioned a couple things right there, but if we were to summarize, what are like the top 3 lessons learned of when to engage the integrator and how to make the process as efficient as possible?
I mean, it seems self-serving, but I would strongly say don't try to go it alone. I mean, we worked with one customer, and he was trying to interpret everything with the fire marshal. And the fire marshal wasn't very well educated, and he, of course, wasn't very well educated. And he basically got the fire marshal to conclude, oh, everything needs to be 2-hour rated in his building. And we stepped in a little late to the game, and we were able to rescue that project. I mean, you're talking tens of thousands, if not hundreds of thousands of dollars of extra cost, because that builder was attempting to figure it out with a fire marshal, hoping he wouldn't have to have a system at all, and winding up getting himself just bombarded with all kinds of extra cost. So that one I think is pretty clear. You really need someone. It's like when we talk to fire marshals, we do all of our research, find out what codes they're using, and then we try to lead them toward the most cost-effective solution that is still code compliant. But a lot of times, if you just ask a fire marshal, what do you want or what are you requiring? Well, let's see, oh, if you're asking me what I want, well, I'd like a Ferrari, and so then that starts becoming the requirement. I'd say that's really one important one. Another one is related to the commercial DAS, which is that not in every single jurisdiction, but in nearly all jurisdictions, you can save money by converging the ERRCS with the commercial DAS. A lot of owners don't know that. That also has to be carefully navigated with the fire marshal. But in doing that, if you're going to be doing a commercial DAS platform, you could save 15-20% typically off of what would have been a standalone system. And while there are a few jurisdictions that don't allow conversions, there are other jurisdictions that are encouraging it. We have one jurisdiction in North Carolina where the fire marshal literally said, I love it that you want to converge a system. I want to do anything I can to encourage this building owner to put in a commercial DAS, because not only do I want my firefighters to be able to talk, I want someone to be able to make an E911 call. And when you think about it, that's pretty darn logical. So I think that's a lesson learned as we try to help educate our customers on the opportunities to get cost synergies. And then the third one is really sort of like the first one, but it's kind of after the fact. Is like the fire marshals really do. They're marshals. They are legal officers, and they really do have the right to change things. So we just had a project we just wrapped up. We got confirmation we wrapped it up today, and honestly, the fire marshal, because the building owner had tried to cut some corners and get some work done without really checking with him, he got mad, and he was upset with the building owner, and you could tell he was making him pay for it. And And every single time he inspected our system and the fire alarm system and everything else he had jurisdiction over, he failed it, and he came up with a different reason to fail it. And so I would just say, similar to, kind of making sure you're working, having an informed party work with the fire marshal, you really got to understand, and it's not, I've sold fire alarm for decades. I've worked with fire marshals for decades, and they have a hard job. They got to make sure people don't lose their lives. And one of the worst things to do is to seem obstinate or resistant to them. And yet we see it all the time. We see people going like, why do I have to have this system? This is ridiculous. I don't have this in my budget. And all they're doing is making it worse. And I would just encourage people, you really want to try to forge a harmonious working relationship with the fire marshal through the entire project. There are probably other lessons learned, honestly, Trey. Actually, a bunch of lessons, but those seem to speak to some of the ones we see more commonly.
Right. Well, I think the goal today was to give people a little bit more of an understanding of the why you need an ERRCS system. What's the process of working with the fire marshal? What are some of the considerations that need to be done? I like what you said about getting the design in place, putting the cabling in place, and then if the requirements still say you need a system, you've done all the pre-work so that adding the electronics, you're not busting up drywall and repainting efforts. And that seems to be the most efficient way to get the systems in place when there's doubt. So anyways, Eric, thanks for sharing
love to help.
On your experiences. And Katie, we thank you for coordinating this, and I'll turn it back over to you.
Well, thanks, Trey. And thank you, Eric, for a great interview and for really shedding some light on ERRCS for us. And
scintillating information, wasn't it, Katie?
Yes, it was. It was very interesting. I found it interesting to learn about. So it was great. And I loved being able to be a part of this and listen to both of you speak on it. So thank you both. And
Sure.
Also thank you to everyone who tunes in and listens to this episode of our Thought Leadership series. To stay up to date on all things Symphony, you can follow us on LinkedIn and Facebook at Symphony Technology Solutions and on Instagram at Symphony Tech Solutions. Furthermore, to check out our Symphony studio, you can subscribe to us on YouTube, where our Thought Leadership series will live, as well as our Technology Harmony podcast. Here at Symphony, our ultimate goal is to make harmonious music out of all the technological noise. Thank you so much for tuning in, and we will see you next time. Okay.
Thank you, Katie. Thank you, Trey.
Thanks, guys.
All right. Thanks, guys.